One of the most popular storage arrays in the industry is the modular array, or sometimes referred to as the mid-range array. And there's a couple of reasons why they are so popular. Number one, the technology is very well established. Mid-range arrays or modular arrays have been around for well over a decade. And number two, they're an entry-level storage system that a customer can start taking the advantages of all the benefits that a storage array offers. And so they're very, very popular. All the major storage vendors in the market have a modular array of some kind. And so it's a very, very common technology you'll see in the data center today. So what makes up a modular array? Well, number one, it has two controllers. A controller is kind of like a server. It has all the traditional elements that we would expect from a hardware perspective that a server would have. It has CPUs, memory, cache. The more proprietary models may have ASICs or FPGAs or some other customized hardware. But for the most part, today most controllers run commodity-based hardware, very similar to what computers run. The big thing is the controller holds the software. Really, the software is where the secret sauce is for the storage array. Really, the rich feature set that storage arrays give you are all within the software. Another big architectural difference with modular arrays is they're typically, not always the case, but typically active-passive in design. And I mean active-passive is from a controller perspective. And we'll dig into more of this in a later slide. Active-passive in my book means that there's no load balancing between controllers, at least in the traditional sense. If you have an application that's writing to a volume using one controller, that workload can't traverse both controllers in most cases. It typically goes through one controller unless there's something that fails on the network that requires some sort of failover. That doesn't mean both controllers aren't active, but they're active and they're independent of each other and only take over for the other one in the case of a failover or a failure somewhere in the topology. Next is they're redundant. So they're highly redundant. They have redundant controllers. We talked about that with two controllers. They typically have multiple CPUs, multiple cache tiers, multiple power supplies. The entire platform is highly redundant and from an uptime perspective are highly available. They're also hot swappable, making them very easy to manage. And because of that, hot swappable makes it where you can perform upgrades and maintenance on storage arrays with really not having to take them down whatsoever. Another big distinction between a modular storage array and some of the other architectures we'll talk about is modular arrays operate in a scale-up or vertical architecture, meaning that you can never go more than two controllers in a modular storage array. You can only increase the amount of disk enclosures or disk shells, so you can only scale up that platform vertically from a storage perspective. You'll always be limited by those two controllers, and so that is a limitation in a modular storage array, and we'll talk about some of the scenarios and why that may be an issue in some environments. So now let's go into a visual and kind of look at the high-level architecture. So a modular storage array, this is a very simple animation, but is typically connected to a LAN or SAN. It's a multi-protocol system for the most part. You have two controllers, an A and a B controller, and each of these are connected to a series of disk shelves. And as you can see, there are 4 network ports connected to both controllers, and they're redundant. So in this case, you have redundant network connections to both controllers. Again, redundancy always is top of mind in the design of any type of storage system. And as you can see, there's multiple redundant connections on the back end connecting those controllers to their disk drives. So a storage controller is really made up of CPUs in this case. So each of these storage controllers has 2 CPUs in a redundant configuration. And it also has multiple cache tiers. And cache is important in storage because it allows you to save data that's highly accessed in a cache tier. It's going to be a lot faster, and there's going to be less latency for the application versus having it on disk. So these systems are smart enough to know that if I'm frequently accessing a file, I'm going to cache it instead of having that application or that user access that data on a disk drive somewhere. And on the back end, they're disk drive, and typically dozens, if not hundreds of disk drives. But the fundamental flaw in this architecture, this design, is you're stuck with these two controllers. So you have to make sure they're sized accordingly and make sure you size for growth. And not only from a capacity standpoint, but just from a performance and IOPS standpoint. And those are some terms we really haven't talked about, but they're key elements and key things that you have to be aware of when you're sizing a modular storage array. And we'll look at some of the design considerations here with regards to controllers failing. And we'll look here at a dual controller design, kind of a deeper level, put it under the magnifying glass and kind of see what I'm referring to. So here we have server 1 and server 2. And they're connected to controller A and controller B. So very similar to the last diagram. And then we have two volumes, let's just say, a collection of disks somewhere on the storage array. We have 1 and 2. And so server 1 is connecting to storage controller A to volume 1. Now this is what I'm talking about. In an active passive design, server 1 is going through controller A to access disk 1 or volume 1. There's no load balancing between A or B, meaning that right now that workload is operating in that fashion. Server 2 is independent of server 1 and it's using controller B, accessing volume 2. Now in this very, very simplistic way of looking at it, you're doing some level of load balancing here, but both workloads are completely independent and there's no load balancing between server 1 and controller A and B and vice versa with server 2. Each are working with their own storage controller. So in this situation, CPU, let's say on the storage controller, is operating about 40%. And let's say on controller B, it's operating at 50%. So in this situation, we have a pretty busy storage array. So what happens if controller A fails? Well, at that point, that workload that was on server 1 accessing volume 1 gets moved to controller B. So B is the failover for controller A. So in this situation now, we have controller B that's taking over both server 1 and server 2's workload needs. And at that point, controller B sees a spike in the CPU. Now all of a sudden the CPU is 90%. So this is at the point where we may start having some performance issues. And this is where, at a more detailed view, where a dual controller design can be somewhat flawed. And it can be a bottleneck that if your controllers are oversubscribed, if you do have a failure, you'll run into an issue where you could bring down your storage system. So in the modular storage design, the key thing to realize is you got two limiting factors. A, the controllers, so you have to size with performance needs in mind. The other thing is the amount of disks that the controller support. So most dual controller designs in this particular scenario, if I'm at 90%, at this point, even when I get the controller A back online, I probably will have to perform some kind of upgrade. And in this model, an upgrade typically would be doing a controller swap. So I may replace the controllers I have with something bigger. In most cases, you don't have to do a complete forklift upgrade of the entire environment. You can reuse some of the disks and the shelves with a larger, beefier controller with more horsepower. But it adds an element of complexity to the environment and typically involves some other vendor to come in and perform this upgrade, and it can be fairly complex to do. So it's a challenge for sure. And so this design is limited in scalability, especially for an environment that's going through a lot of growth. This pretty much covers the modular storage design as well as a dual controller design. So hope you found it helpful. See you in the next lesson.